Welcome back, guys. This is Mr. Hyatt. This is the part 2 of the Chapter 13 flip on renewable energy sources. So we need to start our discussion of the different types of renewable energy resources by looking at what renewable energy is. And remember, our cutoff is 100 years. If the energy can be naturally replenished in less than 100 years, it counts as renewable. So that's why something like wood is considered renewable. It takes a long time to grow back, but less than 100 years, unless we're talking about something like a sequoia or something like that, and we just wouldn't use that as an energy source. Renewable energy will be cheaper if we eliminate inequitable subsidies. Again, why are we subsidizing our history? Let's subsidize our future. If we eliminate those inaccurate prices that are a result of those subsidies, and then we could artificially price non-renewable energy low. If we eliminate those artificial things, but those are all related. It's all goes back to make it cheaper to be responsible, make it more expensive to be irresponsible. So solar energy, we can use passive or active. Passive is going to involve using the heat from the sun to insulate to heat a well-insulated structure. An active solar heating system is going to capture the energy, and it's going to do something with it. Anything that's active is going to use a photovoltaic cell. Here we're looking at, again, passive over here, active over here. We've got a collector that's heating up water. The water comes in to the house, does something that eventually allows the house to be heated. It's active because we're using a solar collector. Here we're using passive solar heat because we just have the windows open. We have high efficiency windows, but we have large windows facing the summer sun, where the summer would be, and especially we have it facing where the winter sun would be. So we've got a straight line. We've got less refraction impacting us here, so we're getting more of that energy intensity in the winter. In the summer, the sun is indirectly shining in, so we don't have to pay as much to cool. We can cool buildings naturally. Open the windows, use fans. There's super insulation that you can use, some of that spray foam insulation that you see. High efficiency windows, which would help us here. Overhangs and awnings on windows would help because it, again, blocks that sunlight, so you don't have to overcome the energy that the sun is bringing in. If you use a light colored roof, that helps you helps you cool buildings, but it hurts your ability to heat the building. So that's kind of a contrasting motivations, I guess. And then we can use geothermal pumps. We'll talk more about geothermal here in just a minute. We can concentrate sunlight. We can use these solar thermal systems. They're going to collect sunlight to boil water, produce steam, to generate electricity. Again, we just have to turn a turbine. So we're collecting the sun's energy and we're doing something with it to create electricity. You see solar cookers are examples of those, but we're going to get low net energy. It's going to use a lot of water, can definitely disrupt desert ecosystems if we're building these in the desert. And then if it's cloudy, it just doesn't work. So a solar cell, sometimes called a PV cell, a photovoltaic cell, is going to convert that solar energy into electric energy. That's what we think of when we think of solar energy. We think about like a solar park or solar panels or something like that. We're talking about a bunch of these photovoltaic cells crammed together. We get thin wafers of silicone. Transparent is important. Silicone is important because it's neutral. The sunlight strikes the cell, releases electrons into the wires. The cells make up panels, and tons of potential in less developed countries. Again, we can leapfrog. There's no reason to have a large energy grid. Let's just develop local smart grids that utilize solar energy. But of course, solar energy isn't perfect, or it would have taken over by now. The key problems are that it's really expensive. It has to be located in a sunny area. It doesn't have to happen in a desert area. We can put them on our homes, but to be most efficient, they need to be in an area that has a ton of sunlight. Fossil fuels are used in production. Solar cells do contain toxic materials that have to be mined. So there are some challenges. It has tons of promise, but we don't have the technology there yet. It's definitely taken off like crazy. We've had a lot of advances in different types of materials that we can use, different media that we can use, things like that. So it's gaining steam. I personally think that solar and wind are going to be what carries us to sustainability. I could be wrong, but that's my personal opinion. The cost of solar energy could drop if we can mass produce them, if we can make better designs that use less rare materials, fewer rare materials, rare minerals, those types of things. And then if we subsidize our future, if we subsidize creating these and make it cheaper, then it's going to be cheaper. So how do we use water? We can use flowing water over dams. We can use tidal flows. We can use ocean waves to generate electricity. But they're not as plentiful because we need a river. We need to be on a coast to take advantage of these. So definitely a ton of potential in specific areas, but someplace like where I live in central Indiana, there's not a ton of potential here. Maybe we could dam our rivers, but we're going to disrupt native habitats and things like that too. So definitely some drawbacks there. But looking at falling and flowing water, hydropower is going to be using a dam, using the kinetic energy of moving water. It is an indirect form of solar energy because the water's moving, because the sun's heating it. And there's some gravity there too. The world's leading renewable energy source used to produce electricity. It is the least expensive. It's used all over the world to create renewable electricity. And there are hydropower plants where water from dam reservoir flows, turns to turbines, and spins to generators. So hydropower doesn't necessarily have to be a dam. It could be like an old school water wheel. And we see those all over the developing world today. A hydropower plant is using more of a dam. And there are micro hydropower generators that are like floating turbines. So it's like almost like a bobber, like a fishing bobber or a buoy or something like that. I've talked about tidal power and wave power. They're definitely limited because you have to be near a coast to be able to do it. The equipment can be damaged by hurricanes and typhoons and things like that are off the coast. Wind power, second fastest growing after solar cells. It tends to be the least expensive because there's a lot less cost in terms of creating it than there is with solar. But it's not without its drawbacks. We're still going to disrupt microclimates and things along those lines. We are going to create some noise pollution and things like that. So we'll get to the advantages and disadvantages here in just a second. If we're using massive turbines, there are kind of two ways to look at wind power. You can do massive wind farms like we see in northern Indiana and really across the United States, Europe, and China. Or you can do local. So one individual can have a couple of smaller wind turbines. We see that some. I can think of a couple off the top of my head here around our community where they're not quite as tall and long bladed turbines. Like it says here, the future appears to be offshore wind farms. The noise pollution is less of an issue. The microclimate disruption is less of an issue. Still an issue. We're still going to have migratory birds that are disrupted and things like that. But check this out. Wind power has the potential to produce 40 times the electricity currently used worldwide. So we don't need coal. We can use wind power. So let's look at the advantages and the disadvantages. Abundant, widely distributed, inexhaustible energy source, high net energy. We get a lot out of it. Low electricity cost relative. It doesn't pollute. The disadvantages is that the largest potential areas are usually rural, so we're talking about places that aren't right next to cities. We're talking about farm ground. We're going to take away farm ground to build wind turbines. We're going to disrupt microclimates. We're going to have air moving in areas that it normally wouldn't be moving in the way that it would be moving. It's going to make the temperature slightly different. We will need a backup power source on calm days. There are days that the wind doesn't blow. And it can for sure cause noise pollution that can mess with folks that have migraine issues and things like that, auditory sensitivity disorders, things along those lines. And they can be an eyesore. Lots of people don't like the way they look. They think that they look like something out of War of the Worlds or something like that. So moving on to biomass. Biomass is going to be matter that was once alive. Could be wood waste, charcoal, crop wastes like stover from corn. Switchgrass is one that we're going to look at specifically. Used for heating, cooking, industrial processes, creating electricity. Wood's renewable only if we manage it well. There are for sure less developed countries that have fuel wood shortages, places where all of their mangrove forests have been cut down. So now they're left with desertified regions that used to be essentially tropical rainforests. We can create biofuels that are liquid or gaseous, basically replacing gasoline. That's what a biofuel does. We can make it from corn, sugarcane, vegetable oils, and lots of different kinds of plants. Can be grown in many different places. So maybe we here in Indiana, we drive our vehicles only on crops made from Indiana. We don't have to import. We don't have to pay taxes. There definitely still would be some kind of a tax, but it won't be an import tax. We don't have to ship things across the ocean. We don't have to process it in Texas and then ship it on a truck here or something along those lines. There's no net increase in CO2 emissions with careful harvesting. You got to remember, if you're using fuels that are made from plants, you had to cut those plants down somehow. So if you drive a tractor, you're releasing carbon dioxide. This stuff can be easy to store and transport because a lot of it can be made inert. So is biodiesel the answer? Maybe. It's made from vegetable oil. There's a guy that was in Bloomington when I was in school there that owned a McDonald's, and he converted his car, it was some sort of a small car, to run on the oil that they used to make the French fries. And you could smell them coming from a mile away. So it's possible to do. The European Union makes most of the biodiesel that's made in the world, 95% of it. But the crops that go into making vegetable oil take a huge amount of land, and it requires fossil fuel. So there are some advantages and definitely some disadvantages. Ethanol is one we're more familiar with because we use it here in the U.S. You see all the different things that you can make ethanol from. Typically, we make it from corn. Sorry about this typo here. Brazil makes a ton from sugarcane because they have a lot of sugarcane. Cellulosic ethanol, I struggle to pronounce that, is something that we'll look at in depth late next week. That's one of the types of fuels that we'll look at and we'll compare. Essentially, growing enough switchgrass would require too much land. That's one of the we can process switchgrass and turn it into ethanol. We're modifying the cellulose. We're looking at algae and bacterial sources for that cellulose, but we're just not quite there yet. That's the one I mentioned the other day. Gas would have to be $7 a gallon for it to be affordable, for it to be economically feasible. So I'll leave off there. I'll finish up in part 3. See you soon.